Hi and welcome to JAD Math Academy. So in the last video and as an introduction to limits, we have seen the meaning of the limits and the difference between the limit and the image. And in today's video, we're going to see how we can find limits, the different methods and the different ways we can use to find the limits. So as we have seen in the last video, that when we talk about limits, we are not interested to know what's happening when x is equal to a. When we want to find the limit when x approaches a, we actually want to know what happens when x is very close to a. So since x is very close to a, the very first thing we might think about is to substitute by the value itself. The limit when x approaches 2. That means that x is very close to 2. So the very first thing we might think about is to substitute by the value itself. So the first way is to substitute. But pay attention, we can do this only if the function is continuous at this point, okay? If the function is discontinuous at 2, so we cannot simply substitute, and we will see that later in details. So now we have no problem, the function is continuous at 2, so we can try to substitute as a first thing. So here we have 2 square 4 minus 4, 0 plus 3 over 4 minus 2, 2. So the limit is equal to 3 over 2. Okay, so this is the first thing we try to do, is to substitute by the value itself if the function is continuous at this point. Now let's see another example. If we want to find the limit when x approaches 0 of x plus 2 square minus 4 over x. Okay, if we try to substitute, we will find 0 plus 2, 2 square 4, 4 minus 4, 0 over 0. It's an indeterminate form. Indeterminate form. Well, normally in limits, when we have something over 0, something over 0 is not an indeterminate form in limits, because from the definition of limits, we know that x is not equal to 0. It's just close to 0. It's very small. It's very small, is very close to 0, but not equal to 0. So something over 0 is not considered to be indeterminate, but 0 over 0 is indeterminate form. The indeterminate forms we have for the limits, we have infinity minus infinity, 0 multiplied by infinity, 0 over 0, infinity over infinity, 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. So these are the indeterminate forms we have. Since 0 over 0 is an indeterminate form, so we can't simply substitute by 0, but we have to do something. We have to play a little bit with this expression before we can substitute. So if you notice here, we have a remarkable identity. So the first thing we think about is to expand this expression. we will try to open up parentheses. So we will get limit when x tends to 0 of x squared plus 2x plus 4 minus 4 over x. So x squared plus 2x over x is x multiplied by x plus 2 over x. We simplify by x and we have x plus 2. Now we can substitute by 0 and we have the result, which is 2. Okay, so whenever we try to substitute and we get an indeterminate form, it means that we have to do some simplifications, some changes, and we have to play a little bit with the expression of the function by some of the ways to simplify the expression, and then we substitute and we get the result. So now let's move to the third example. If you want to find the limit when x approaches 3 of x squared minus 2x minus 3 over x squared minus 9, if we try to substitute, we get 9 minus 6 minus 3, it's 0, over 9 minus 9, 0. So again, we got an indeterminate form. So here we have to think to do something. And what can we do in this case? We don't even have parentheses to open or to expand. But if you notice, we have a remarkable identity in the denominator. So this expression, we can write it as x plus 3 multiplied by x minus 3, right? So limit when x tends to 3. This minus 2x, we will try to write it as x squared minus 3x plus x. Okay, minus 2x is equal to minus 3x plus x, minus 3 over x plus 3, x minus 3, right? Well, now we will try to factor by x. So this is what we will do. It's factoring. So we have x squared and x. We try to factor by x, and we have x multiplied by x plus 1. Okay? X multiplied by x plus 1. And here we have minus 3 multiplied by x plus 1. X plus 3 multiplied by x minus 3. So we will factor by this term, x plus 1 multiplied by x minus 3 over x plus 3 multiplied by x minus 3, and we simplify by x minus 3 and we have x plus 1 over x plus 3. Now we can substitute by 3 and we get 3 plus 1, 4 over 3 plus 3, 6. Right? So 4 over 6, which is 2 over 3. And this is the result. So the limit is 2 over 3. Now let's move to another example. The limit when x approaches 0 of 1 over x plus 2 minus 1 over 2 over x. If we try to substitute by 0, we get 1 over 2 minus 1 over 2 is 0 over 0 indeterminate form. So we got an indeterminate form. So what we can do immediately, what we think about is to get a common denominator since we have fractions here. So the first thing we think about is to get a common denominator. So the limit when x tends to 0, here we try to get a common denominator of these two fractions. So the common denominator is 2 multiplied by x plus 2. Here we will have 2 minus, and here we will have x minus 2, right? Over x. 2 minus 2, it's equal to limits when x approaches 0 of minus x over 2 multiplied by x plus 2 multiplied by x. So we will simplify by x, limit when x tends to 0 of minus 1 over 2 multiplied by x plus 2. Okay, so this is the simplified form we have got, and now we can substitute by 0. So if we substitute by 0, we get minus 1 over 2 multiplied by 2, 4. It's minus 1 over 4. So now let's move to the next example. The limit when x approaches 8 of the square root of x plus 1 minus 3 over x minus 8. Okay, if we try to substitute by 8, we get the square root of 9, it's 3, minus 3, it's 0, over 8 minus 8, 0. It's an indeterminate form. So what we can do now, since we have a square root in the numerator, so the first thing we think about is to multiply by conjugate. Multiply by conjugate. So it's equal to the limit when x approaches 8 of square root of x plus 1 minus 3 over x minus 8. We will multiply by the conjugate of this numerator, which is the square root of x plus 1 plus 3. Okay, here we have minus plus. So this is the conjugate. And we divide by the same. Okay, so this is equal to the limit when x approaches 8 of this multiplied by this. It's a remarkable identity. A minus b multiplied by a plus b is a square minus b square. So it's the square root of x plus 1 square. It's x plus 1 minus 3 square, which is 9, over x minus 8 multiplied by square root of x plus 1 plus 3. Okay, so here 1 minus 9 is minus 8. So here we simplify by x minus 8, x minus 8. So we will have 1 over the square root of x plus 1 plus 3, and we try to substitute by 8, and we get 1 over the square root of 8 plus 1, 9. The square root of 9 is 3, plus 3, it's 6. So the result is 1 over 6. So as I told you in the beginning, that if we try to find, or if we want to find the limit at a point where the function is discontinuous, so we can just simply substitute. And here we have an example. Here we want to find the limit when x approaches 2 of the absolute value of x minus 2 over x minus 2. So here we can simply simplify by x minus 2 over x minus 2, and we get 1, because we have an absolute value. This term inside will be positive if x is greater than 2, and will be negative if x is less than 2. So actually 2 is a point of discontinuity for this function. So here we have that the absolute value of x minus 2 will be equal to x minus 2 if x is greater than 2, and will be equal to minus x plus 2 if x is less than 2. So in this case, what we need to do is to find the left and the right sided limits. The right and left sided limits. Okay, so the limit when x approaches 2 from the right of the absolute value of x minus 2 over x minus 2 is equal to the limit when x approaches 2 from the right of, when x approaches 2 from the right, we have this case, right? From the right means that we are here from the right. So x is greater than 2. X is greater than 2. So the absolute value is equal to x minus 2 over x minus 2 is equal to 1. Okay, so the right-sided limit is equal to 1. Now let's find the left-sided limit. The limit when x approaches 2 from the left of the absolute value of x minus 2 over x minus 2 is equal to, so when x approaches 2 from the left side, so we have x is less than 2. X is less than 2, so we have this case when the absolute value is equal to minus x plus 2. Minus x plus 2 over x minus 2. It's minus x minus 2 over x minus 2. We simplify and we find minus 1. So the left-sided limit is minus 1 and the right-sided limit is 1. And as we have seen in the first video, that the right-sided and the left-sided limits must be equal. They should have the same value, but here we have two different values, 1 and minus 1. So we say that the limit when x tends to 2 of the absolute value of x minus 2 over x minus 2 does not exist. So as we have seen till now, when we can't just simply substitute, we should try to notice how is the expression of the function. It will give us idea of what we should do. If we have an expression to expand, so the first thing we should do is to open up the parentheses. If we notice that we have a remarkable identity, so we try to just factor the terms to simplify the expression. If we have fractions, so we try to find or to get the common denominator to simplify the expression. If we have a square root in the denominator, we try to multiply by the conjugate again to simplify the expression before we can just substitute by the value. And as I said, sometimes if the function is discontinuous at that point, we cannot just substitute by the value, but we have to evaluate the right-sided limit and the left-sided limit, as we have seen in the last example. The last thing that we can do is to use the standard limits of the common functions. We know the sinus, cosinus, log, the e function, all those functions that we know the limits or the standard limits, we can use them when we have a function that looks like one of the common or the standard limits that we know. So for example, here we want to find the limit when x tends to 0 of sinus 2x over 4x. So the standard limit that we know and that is similar to this expression is the limit when x tends to 0 of sinus x over x is equal to 1. Okay, so this is a standard limit of a common function that we know. The limit when x approaches 0 of sinus x over x is 1. Okay, so what we can do here is to write this expression in terms of this one. So it's equal to the limit when x approaches 0 of sinus 2x over 2 multiplied by 2x, right? 4x is 2 multiplied by 2x. So we have 2x here and 2x here. When x approaches 0, 2x also approaches 0. Okay, so the limit when x approaches 0 of sinus 2x over 2x is 1. So it's equal to limit when x approaches 0 of, we will keep this 2 we have in the denominator, it's 1 over 2 multiplied by sinus 2x over 2x, the limit is equal to 1. And the result is 1 over 2. So as a summary, we can say that the first thing we always try to do is to substitute by the value itself if it's not a point where the function is discontinuous. Okay, if we get an indeterminate form, so we look at the form or at the expression of the function, it will give us an idea of what we should do. So sometimes we will have to expand if we have an expression that we can expand. Sometimes we will have to factor when we have a remarkable identity, and sometimes we will have to get a common denominator if we have fractions like this in order to simplify the expression of the function. Sometimes we will have to multiply by conjugate if we have a square root in the numerator. And sometimes if we want to find the limit at a point where the function is discontinuous, we have to find the right and the left-sided limits. And as a last thing, when we have a function that looks like one of the standard limits that we know, so we can use one of the standard limits of the common functions that we know to simplify the expression of the function and then to substitute and find the result. So actually there is not a standard method or one method that works for all the functions. Sometimes we have to look at the expression of the function itself. It will give us the answer of what should we do or what method we have to use to find the answer. So that was all for this video. I hope it was useful and see you in the next video. Bye bye.